Okay, so we look at some C++ code as a kind of review of C++ and the use of arrays and pointers and objects. So all these things we should have covered in earlier programming class like 118 or 119. So this is a review. Okay, all right. Okay, so we have say standard C++ code. You always include some header files like the IO string for doing input output, stdlib.h for using some library functions, as we'll see some as you go through some examples. Then time.h if you want to generate random numbers, you have to use both stdlib.h and time.h. Okay. All right. So now you say int main, and since you say int, you have to say return, typically say return 0 if you're doing a normal return. If you're doing an abnormal return, like suddenly stopping the program due to some error, then you can say return -1. All right. Now you input, say, so in this example, what I'm going to do is I am going to create an array and using pointers and then process the array. Okay, so you need to get input for the user from the user for the array size. So you do that. So declare array size as integer. You see out to ask the user to enter the array size and see in array size. So this will assign a value for array size, whatever you enter as input. Similarly, you ask the user to enter a maximum value for an element in the array. So the idea is you're going to generate an array of random integers starting from 1 to this max value. So this is the critical statement. So with this statement, you're declaring a block of array. Each element in this block is going to store an integer. Okay, and the starting address of this integer array is going to be stored in what is called the array pointer. Okay, so let me pull out this code here. So this is what it's going to look like. So you're going to create consecutive blocks of integers. So if the first integer is stored at address 200, now the second integer will be stored at address 204 because each integer takes 4 bytes of memory. Okay. Then the third integer is going to be stored at address 208 and so on. From indexing point of view, it is at index 0, 1, 2, 3 and so on. Now it is this 200 that is going to be stored in this pointer value. So this array is a pointer. It stores a memory address and it stores the memory address of the first integer in the block. Even though you're storing, creating consecutive blocks of integers, you remember only the address of the first integer. Now when I say I want to access the element at index 2, okay, so then say this A is this array, then when I say A of 2, what is going to happen is this A stores this address 200, right? So here I am using A as the variable for the array pointer. So this 200 plus this index 2 times 4, where why 4? Each integer is 4 bytes of memory. So 200 plus 2 times 4 is 208. So that is how you are able to access the address 208 and you can access the element at that index, at that address. So which means if you want to access any element in the array at any index, you can access it right away. You don't have to go through sequentially. So if I want to access A of 3, you can say that A of 3 means 200 is the base address plus the index 3 times 4, so that is 212. So you can right away go to address 212 and access the element at that address. So you don't have to really go through sequentially each integer and then go to that particular index. So that means accessing an array using the base address can be done in constant time. When I say constant time, means it's just like that one multiplication, 3 times 4. That's multiplication is a basic operation because it's more time consuming than plus. So 200 plus 3 times 4, 212. So you can do it in state of one time. So that's something I did not mention in the earlier module. So if an algorithm takes always the same number of basic operations, which means again it does not grow with the input size, then we can say it is constant time complexity, and we indicate that by theta of 1. Okay. Alright, so in the code, I have just created the consecutive block of integers. I have not assigned the values. So this is what we're going to do now. As I said, I'm going to fill up this array using random integers. So srand is the function that you can kind of use to initialize the random number generator. And what is the value you are initializing it with? So when I say time of null, it gives the current system time, and that is what we are going to use as a seed for the random number generator. So this seed is important because if you pass a different seed, you're going to get a different sequence of random numbers. So that means if you pass the same seed each time you run this program, you're going to get the same set of random numbers, same sequence of random numbers. So that is why we are passing system time as a seed, because the system time changes each time you run the program, so you will get a different sequence of random numbers each time you run the program. So now we run a for loop for int I equals 0 to I less than array size, and then so I generate a random number using this rand function. So this is initializing the random number generator. Now I can call the rand function, and it returns some large integer. Now we want all the integers to be kind of within this range of 1 to max value, right? That's what you want to fill up the array with. So what you do first is you do rand of, generate the large integer, divide by max value, and take the mod. So that's the reminder. So when you divide something by max value, say max value is 10, then the remainder is going to be between 0 to 9. From 0 to 9. So when you divide something by max value, the remainder could be anywhere from 0 to max value minus 1. But we want all the integers to be from 1 to max value. So that is why I do add a 1 plus to it. So 1 plus something from 0 to max value minus 1 will put the integers that you generate in the range of 1 to max value. So you then store the value of array of I equals that whatever the result will come up with. Okay. So now you go at the end of the for loop, you have filled the array with all these random integers. So let us say you want to add all these integers and print the sum. So I can have a function called add all that will do this. So you need to pass the array pointer. So you really pass the base address, the starting address of the array, and the array size. So let's go see the add all function. So you are capturing that using a pointer variable. Remember, it is starting with a capital A, so this is a pointer to the array, and you say because you indicated the star. Okay, so the star is to indicate it's a pointer, and it captures that address, which is whatever the address say 200 is. Then array size. Then declare a local variable sum to be 0, and then run a for loop from I equals 0 to I less than this array size. So this is what it is. So array of I. So this array is storing the base address whatever you are passing, and of I means you can access whatever the index you want right away in constant time. It is adding the values. Okay, so sum plus equals array of I, and then you can finally return sum. Now that value will be returned here, so you can print that sum value. Okay. Now remember, this is what I emphasize. This array is a different pointer, and that capital A array is a different pointer. So both are storing the address 200 and pointing to that address, but they're two different pointer variables. The scope of this array pointer is within this function at all, whereas the scope of this array pointer is this main function when we're using it. Now let us say I want to turn all the elements to be negative. So because we generated here say 1 to max value, right? So let us say I want to turn everything to be to the negative of what we have here. So I can have a function turn negative, but remember I want to turn the contents of the array. Okay, so let us see how we do this. So again, we have a consecutive block of integers, and this array pointer is pointing to the base address 200. Alright, so turn negative, so this capital array pointer is also going to point to that base address 200. And now I am declaring a new block of integers. Now I am not going to change the integers in the current block that we randomly created in the main function. I am going to create a new block of integers of array size. So this negative array is a pointer storing the base address of that new block that we just created. And then we are going to access the original array of I and do a multiplication, -1 times whatever the value is, and going to assign that value to negative array of I. Okay, so and then return negative array. So you're returning the address of the pointer, address of the first element in the negative array. Okay, so returning the base address of the negative array. And using the base, you can capture the base address using this neg array, which is also a pointer, storing the address of that first element in the negative array. And using that, you can run a loop and access every element in the negative array and print the value. Now, so you have now two integer arrays in memory. So the one original array we just created from 1 to max value, and neg array is a pointer to the negative second array that we just created that stores the negative values of the elements in the original array. So we can go through a for loop and print the contents of the negative array. Now after done with everything, it's a good programming practice to delete the memory that we allocated for the arrays. So when I say delete, and then you have to put empty square bracket like this and write the pointer name, so that will clear that block that we just allocated. Similarly, we have this neg array pointing to the second block that we just created, and that will also be deleted now. Okay, let me stop this video.